Hello everyone, dear lovely students, pleasant evening all of you. Hi, hi. How are you dear students? Doing good? Energy bhaiya, where is energy in the class? Add energy to the class. So just now physics class is done. Sir has started vectors, types of vectors, right? So in a way, matrix at one point of time, matrix will also act as a vector in higher math. Okay, good evening everyone. Yes, number, non-negative, text all of you, non-negative, number, good evening, number. Number is the ruler of the universe. Number is the ruler of the universe. Yes? Yeah. Right. Thank you. Thank you, dear students. We shall start the lecture today. If you are all ready, let me start. In the last class, I have introduced matrix. A matrix is a rectangular arrangement of numbers in rows and columns. Then I have seen, we've discussed about order of the matrix. The number of rows versus columns gives the order of the matrix. Types of matrices based on order. Suppose the matrix order is m by n. If m not equal to n, we call it as rectangular. M is equal to n, we call it as square matrix. If there is only one row, we call it as row matrix. Only one column, we call it as column matrix, right? Then in a square matrix, we have defined the principal diagonal. Based on the principal diagonal, we have defined upper triangular matrix, lower triangular matrix, triangular matrix, diagonal matrix, scalar matrix, unit matrix, which is nothing but identity matrix. Then we have separately defined a null matrix whose all entries are 0, right? Yeah, Shiva, shall I repeat? Just types of matrices, that's all, right? After the types of matrices, we discuss equality of matrices. Two matrices are said to be equal if they have same order and the corresponding elements are equal, right? Good evening, Harsha. Yeah. Trace of a matrix is nothing but, if it is a square matrix, trace is defined only for a square matrix. For a square matrix, trace is sum of all elements in the principal diagonal. Okay, we'll discuss that trace, don't worry, we'll discuss about it, right? Chalo, coming to today's lecture. And one more important point, in matrices, order axioms are not defined. That means big matrix, small matrix, positive matrix, negative matrix are meaningless. Okay, fine, thank you. Right, dear students, are you all ready to start the today's lecture? Fine, thank you, Shyamala. Everyone, say, all of you text, ready sir, then we shall start today's lecture. Everybody say, ready sir, text here, we'll see. All of you, yes, we are ready. I want every student should attend the class with utmost energy. I need energy in the class, then we shall discuss. Thank you everyone. Yeah, chalo, we shall continue. Okay, now, so algebra of matrices we need to discuss. So first we shall define transpose of a matrix, followed by addition, multiplication, all these things we will discuss. Okay, so you are saying, sir, please explain difference between scalar matrix and identity matrix. It's simple. Scalar matrix means, I can say, scalar matrix, somebody is asking. Scalar matrix means the principal diagonal elements must be same and the other elements must be 0. We can call it as a scalar matrix. Even identity matrix is also a scalar, but it must be 1 if principal diagonal entries are 1 and remaining entries are 0. We call it as unit matrix. In turn, it acts as a, yeah, right? Fine, got it? Clear? Chalo. Now, we shall go to the point. Today's point number 1. Dear students, point number 1, yeah, transpose of a matrix. Suppose A is a 2 by 3 matrix given by 5, 6, minus 8, 7, 1 by 2, 4. Some matrix is given of order 2 by 3. A is a matrix of order 2 by 3 suppose. Transpose of a matrix is nothing but transpose. We write like this, A transpose. So just you try to write the rows as columns. You see, first row you try to write as first column, second row you try to write as second column. So this matrix will become 3 rows and 2 columns. So A transpose, transpose in the sense the rows are to be written like columns. Clear? It's very simple, very simple. Is it clear, dear students? If A is a matrix of order 2 by 3, transpose will have order 3 by 2. Fine? Fine? For example, B is a matrix, say 6, 1, 5, 4, and B transpose will become, the first row you have to write like first column, second row you have to write as second column. Since it is 2 by 2, it is also 2 by 2. Got it, everyone? Clear? And here, if A transpose, can I say that A transpose whole transpose? If you transpose A, what will you get? Repeat, first row you write as first column, second row you write as second column, third row you write as third column. You will get A itself. So A transpose whole transpose is nothing but A. Okay. Matrix, please tell definition of a matrix. Matrix is just an arrangement of numbers in rows and columns. That's it. If mn elements are arranged in m rows and n columns, it is a matrix. That's it. That's it. That's it. So don't worry much about, okay, all these things. Okay, fine. Next, multiplication of a matrix with a scalar. You see, second point, you see transpose is very clear. Transpose in the sense, for a matrix, transpose in the sense simply a new matrix. A transpose of a matrix is a new matrix. Simply you just write rows as columns. First row you write as first column, second row you write as second column. Fine, that is transpose. A transpose whole transpose will become A. Next, you see, second point, today's second point is, everyone, multiplication with a scalar. Suppose you are given a matrix, bhaiya. A is a matrix, say 5, 6, 7, minus 2. So what do you mean by multiplying a matrix with a number? You see, suppose if you want 3A, so multiplication of a matrix with a number is very simple. You multiply each and every entry with the number. You multiply this with 3, this becomes 15, this is 18, this is 21, this is minus 6. That's it. That's it. Very simple. Very simple. What is right? Fine. Then if A is this, can you tell me how to find minus 2A? Minus 2A means multiplying A with minus 2. Okay. Multiplying A with minus 2. Multiply here. This is minus 10. This is minus 12. Minus 14. 4. That's it. Multiplying a matrix with a number is very, very simple. Now from this, dear students, what do you mean by minus A? The meaning of minus A matrix is minus 1 into A. You just write minus A here, minus 5, minus 6, minus 7, 2. That's it. That's it. So dear students, this is today's second point. Is it clear everyone? Today's first point is, if a matrix is given, how to find its transpose. Second, if a matrix is given, how to multiply a matrix with a number. Sir, in which situations we use the transpose? We'll tell you, takes time. You see, first we are giving all the definitions, first we are trying to learn the language of matrices, then we start where to use, how to use, all these things. Clear everyone? Clear these 2 points? First you learn the language of matrices. Okay, I am just introducing the terms. Now algebra of matrices, coming to addition of matrices, right? Addition of matrices. Do remember dear students, suppose A is a matrix, B is a matrix, I want to define addition. So we define addition of 2 matrices only when they have same order. Only when they have same order. Do remember, if 2 matrices have same order, then only we can add. If they are, yeah, thank you. If they have different order, we cannot add. Sorry bhaiya, we cannot add. Addition is not possible, we'll say. Suppose dear students, A is a matrix, say 3, -1, 4, 6, 2, 5. This is matrix A. Suppose B is another matrix, 1, 5, 6, 2, -4, 3. You see, first matrix is having order 2 by 3, second matrix is also having order 2 by 3. Since their orders are same, we can add A plus B. The resultant, addition process is adding the corresponding elements. So simple, yeah. 3 plus 1, 4, -1 plus 5, 4, 4 plus 6, 10, 6 plus 2, 8, 2 minus 4, -2, 5 plus 3, 8, which is again a 2 by 3 matrix. Clear? Clear everyone? How simple it is. These will also be given in JEE. JEE is so simple. Who told that JEE is very difficult? Same, very easy, very easy. Clear everyone? Yeah. So 2 by 3 and 3 by 2. No. You take, if the matrices are of different order, we cannot add 2 matrices. Do remember, 2 matrices are compatible for addition if they have same order. That's it. So 2 matrices of different order, you cannot add the matrices. Clear everyone? Clear? So there itself, I mean to say, I'd like to define A minus B also. Just A minus B means A plus -1 into B. That means just subtract, no much mathematics. A minus B. 3 minus 1 is 2, -1 minus 5 is -6, 4 minus 6 is -2, 6 minus 2 is 4, 2 plus 4 is 6, 5 minus 3 is 2. It will also be a matrix of same order. So dear students, by this time you must understand 3 things. How to multiply a matrix with a number. Clear? How to multiply a matrix with a number. Second, if 2 matrices of same order are given, can you add, can you subtract, can you add, can you subtract? Clear? Clear everyone? Those who have understand up to here, give thumbs up, and likes. You didn't like the video, you didn't like, this is why I'm not getting energy. Like it, amma. You forgot to like it. Okay? Right? Come on. Yes. Chalo. So, as far as I'll give you, Harsha, how to multiply, everything I'll give you. Don't worry. Okay? Fine. Now, you see, addition of matrices, let me give certain important observations. Property number 1, you see, please note, if 2 matrices are given, generally entries are numbers. Can I say A plus B is equal to B plus A? Am I correct? obviously you add A plus B or B plus A, you will get the same. Correct. The next associative law, A plus B plus C is same as A plus B plus C. Do remember. It means first you add, there are three matrices. First you add B plus C, then A is added to this. First you add A plus B, then C is added to this. Both will be the same. That means you can brackets you can maintain in any way. This is called associative law. That is fine. Next, dear students, you see, to any matrix, if you add null matrix of same order or null matrix plus any matrix of same order will give you A. Am I correct? Very simple. You take a 2 by 2 matrix 1, 3, 5, 4, add this with the null matrix. What will you get? The matrix itself. A plus 0 matrix gives the same matrix. Correct? Correct? Yeah, simple things, very simple things. Another point, A plus, if you add minus A or minus A plus A, you will get null matrix. You see, in 6th class you might have learned this property is called commutative law, this is associative law, this is existence of identity, this is additive inverse. For the matrix A, additive inverse is minus A, right? For the matrix A, additive inverse is minus A, correct, because if you add these two, you are going to get the identity 0. Simple? Clear, everyone? This is, so I am not going to, because this is very simple, you can do well. So addition of matrices as easy as simple addition, right? So let us go to the next point, multiplication of matrices. All of you listen to this. This we define in a different way. This we are going to do in a different way. So all of you pay attention here. All of you pay attention here. Multiplication of matrices is not like just multiplying. Okay. You see, first point, dear students, suppose A is a matrix, B is a matrix. So suppose A is a matrix of order m by p, B is a matrix of order p by n. You see, first important point, what is the weightage of matrix in J is huge weightage. You will get 2 to 3 questions in from matrices. Generally 30 questions, 30 chapters. There will be 30 chapters in math, 25 questions in main and 17 questions in advanced. So generally you will get 1 question from every chapter, but matrices is the chapter where you can expect 2 questions surely, sometimes 3. So we can say that matrices is high weightage chapter. Okay, right. Right, you see, A is a matrix of order m by p. First point you have to listen. If you have decided to multiply 2 matrices, the first condition that he has to satisfy is, first matrix number of columns, second matrix number of rows must be same. Then only you can multiply 2 matrices, right? If 2 matrices are given of order m by p, p by n, so the number of columns of the first matrix, number of rows of the second matrix must be same, then only you can multiply and the resultant matrix will maintain the order m by n. So finally you will get AB matrix, its order will be m by n. Suppose these two are not equal, you cannot multiply. Multiplication is not defined between them, okay, right? So let me take some example. Be clear, fine. You see, suppose let me take a 2 by 3 matrix, 2, 1, 5, 3, 2, 4. This is matrix A. Matrix B is 5, 1, 6, 2, 4, 3, 1, 2, minus 2. Something is given. All of you listen to me carefully. All of you listen to me carefully, very, very important. You see, I am going to multiply 2 matrices. What is the order of the first matrix? 2 by 3. Second matrix 3 by 3. You see, these two are same. So, are they compatible for multiplication? Can we multiply these two matrices? Come on, tell me all of you. Can we multiply these two matrices? Can we multiply? Yes or no? Yes or no? Okay. Yes. So, now you see, yes, we can multiply. The resultant matrix order will be 2 by 3. Now, let me tell you how to multiply. You see, you have to do like, first you start with first row. Start batting with first row. Start batting with first row. Start batting with first row. This first row first bats with first column. First row started with batting. Okay, right? First row started with batting. It does batting with the first column. How to multiply? You see, first row first column means 2 into 5, 10 plus 1 into 2, 2 plus 5 into 1, 5. You will get 17. Do you understand this step, everyone? This is very important step. Is it clear? First row started for batting. It batted with first column. Okay. So, it fought with first column. Here 3 numbers. 2 into 5 plus 1 into 2 plus 5 into 1. Okay. Then one element you got 17. Then next continue with first row. Then go to second column. Yeah, start 1 into 2, 2 plus 1 into 4, 4 plus 5 into 2, 10. So you will get 16. How 17? Let me repeat. How 17? Let me repeat. You see, first row, first column I have taken. Yeah, you see, first I have started batting with first row, first column. You see, first row, first column. 3 numbers here, 3 numbers here. 2 into 5, you see, 10 plus 1 into 2, 12 plus 5 into 1. Here I have written, you see, 17. 17. The next continue with first row, second column. Come on, first row, second column. 2 into 1, 2 plus 1 into 4, 4 plus 5 into 2, 10. You got 16 this time. 16 this time. Next, first row, third column. First row you do with third column. You see, 2 into 6, 12 plus 1 into 3, 3 plus 5 into minus 2, minus 10. 15 minus 10, 5 you will get. Clear? So, batting with first row is done. I have started with first row, I have done with first column, second column, third column. Columns are done, so here first row is done. Clear everyone? Clear everyone how to multiply with a row? Is it done? Is it done? Yes. Clear everyone? Then next you start with second row. Second row is this. Start with again second row first column. Second row first column. Again 15 plus 4 19 plus 4 23. This is 23. Okay. Next number all of you try. All of you try the next number. Second row second column. 3 plus 8. 11. 11 plus 8 19. Okay. 11 plus 8 19. The next second row third column. 3 6 are 18 plus 6 which is 24 minus 6 which is 18. You see 18 plus 6 yeah minus 8. You see this and this 3 6 are 18 plus 6 minus 8. So which is 16. 16. You got this. Okay. So which is a 2 by 3 matrix. Clear everyone? Clear? So this is how we multiply two matrices. First matrix with order 2 by 3, second matrix of order 3 by 3. Just multiply like this. So, in the same example, can you tell me what about BA? What about BA? What about BA? How 2 by 3? This is 2 by 3. You see, 2 by 3 means it is having 2 rows, 3 columns. So, 2 by 3, correct? 2 by 3 we should read, isn't it? It is having 2 rows, 3 columns, right? So, this is 2 by 3. Fine. Yeah. Now, what about BA? Can someone say? What about BA? What about BA? What can you say? BA in the sense, first B matrix order is 3 by 3, A matrix order is 2 by 3. These two are not same, and hence BA is not possible. BA is not defined. BA is not defined. That means one observation, AB matrix, BA matrix need not be the same. Am I correct? AB and BA need not be equal. Of course, multiplication possible also, no guarantee that they are the same. No guarantee that they are the same. Am I correct? Am I correct? Okay, fine. Now, let us try one more example. All of you try to find this product. A is, okay, let me write here A, this is 2, 1, 3, 3, 1, 4. This is A. B is 1, 2, 5, 4, 1, 3. Yeah, find AB everyone, find AB all of you, find AB matrix. A matrix is having 2 by 3 order, B matrix is having 3 by 2. These two are same, the product gives a 2 by 2 matrix. The product will be a 2 by 2 matrix, right? Yeah. So, come on, this is the 3 by 2 matrix. Now you see, start with first row, first column. Come on, 2 plus 5, 7 plus 3, 10. Correct? Then first row, continue with first row. First row, second column, 4 plus 4, 8 plus 9, 17. Correct everyone? Yeah. Correct? Simple. Now first row is done. So shift to second row. If you are shifting to second row here, you have to write in second row. Second row, first column, 3 plus 5, 8, 8 plus 4, 12. Now second row, second column, 6 plus 4, 10, 10 plus 12, 22. This is a 2 by 2 matrix. Clear how to find a 2 by 2, how to multiply AB? In the same case you find BA. BA. You see B is 1, 2, 5, 4, 1, 3 and A is 2, 1, 3, 3, 1, 4. You see here, this is a 3 by 2 matrix, this is a 2 by 3 matrix. You see, the result will be a 3 by 3 matrix. Result will be a 3 by 3 matrix. Okay. So now you just multiply. Start with first row, first column, 2 plus 6, which is 8. First row, second column, 1 plus 2, which is 3. First row, third column, 3 plus 8, 11. That's all. First row is done. That's all. First row is done. Similarly, start with second row, first column, 10 plus 12, 22. Second row, second column, 5 plus 4, 9. Second row, third column, 15 plus 16, 31. Second row is done. Second row is done. Then third row, first column, 2 plus 9, 11. 1 plus 3, 4. This is 3 plus 12, 15. So, which is a 3 by 3 matrix. So, dear friends, I mean to say here, one is a 2 by 2 matrix, other is a 3 by 3 matrix. Here also AB and BA are not same. Sometimes they may have same order, they may not be equal, but still sometimes they may be equal also, they may be equal also. Okay, okay, clear, clear, fine, right, fine. So let us have certain important observations. Now by this time, dear students, you have seen how to find transpose of a matrix, how to multiply a matrix with a number, how to add two matrices of same order, how to subtract two matrices of same order, how to multiply two matrices. These skills, these definitions you have seen. How many of you understand this? Tell me here. Those who have followed these comfortably, just give a like, give a thumbs up, give a like. Those who have followed all this, give a like. Let me see. Come on, everyone, respond. Yeah, respond. Those who understood, give a like. Means thumbs up. Everyone, let me see. So really interesting. Many students are consistently watching the lecture, following the lectures. I really appreciate, dear students. Okay, fine. Yeah. Okay. Now let us go to very important part of some observation related to multiplications. Okay. Yeah. So number one, guys, regarding multiplication of matrices, first point, generally AB and BA need not be equal. Not equal in the sense, sometimes they may be equal. Okay, sometimes they may be equal, generally not equal. Not equal means if it fails to be equal in some case, we say not equal. Okay, fine. First point. Second point is, in matrix multiplication, you can observe matrix multiplication is associative. A into BC can be written as AB into C. A into BC can be written as AB into C. It is not having commutative law, but it is satisfying associative law. Right? Right, everyone? Fine. Fine. Yeah. Oh, you learn math by my classes and get 99% in maths in JEE. That's great, Bhavani Shankar. Then what are you watching here? Fine, anyhow, thank you. Right. So, yeah, dear students, A into BC can be written here AB into C. Okay. Next, most important property, peculiar property related to matrix multiplication I am going to give. Next 10 to 15 minutes are very important. Don't leave the class. Don't leave the class. Next 10 to 15 minutes are heart of today's lecture. Ready, dear students? I am going to give up wonderful points related to matrix multiplication. Very peculiar points. So somewhat different points. Okay, right, everyone? Right? Clear? And just give a like so that your friends will also join. So all of you like the video. Those who didn't subscribe to Sri Chaitanya channel. Yeah, right, everyone? Like the video. Everybody will be joining here. They will be watching our session. Come on, quick. We shall go to the important points. Yes, thank you. So matrix multiplication is not commutative, not associative. The next, associative. Third point is, suppose you know that B is equal to C. You want to multiply a matrix with a number. You want to multiply a matrix with, you want to multiply a matrix on both sides. Okay. Do remember, you want to multiply both sides of this equation with a matrix. Then you do either pre-multiplication or post-multiplication. That means if you want to multiply with A, both sides you multiply with A on left side. AB is equal to AC. Or if you want, you can multiply both sides, here right side. BA is equal to CA. but you shouldn't do like. You see, left side you multiplied here, A you are multiplying on both sides, but one side on left, one side on the right you shouldn't do. Got my point? If at all you are multiplying with a matrix on both sides of an equation, you have to do either pre-multiplication or post-multiplication. Clear? So it is not allowed like AB is equal to CA. That is one point. Next important point is, generally in matrices, there is a possibility that AB is equal to 0. Suppose product of two matrices is 0. It generally in numbers, if x into y is 0 means either x is 0 or y is 0 in numbers. But in matrices there is a possibility that both may be non-zero but the product may be 0. The best example I can say here is, you see, A matrix is 1 0 0 0, B matrix is, you can write 0 0 0 1. Okay, you see, this is non-zero, this is non-zero, but the product becomes 0 0 0 0. So in matrices a very important point is, even though A, B both are non-zero matrices, the product can be 0, and hence AB is equal to 0 doesn't imply either A is 0 or B is 0. Somebody is asking to repeat the first point. For a matrix equation, if you want to multiply both sides with a matrix, do remember that you have to do either pre-multiplication or post-multiplication. Both sides you multiply on left side, or both sides you can multiply A such a way that A is on right side. Got it? This is very important point. Second thing, in matrices AB is equal to 0 does not imply, generally in numbers xy is equal to 0, we feel like either x is 0 or y is 0, so no guarantee that here A is 0 or B is 0. Next, matrix multiplication has distributive property. That means A multiplied by B plus C, you can write like AB plus AC. Similarly, B plus C multiplied by A, right multiplication, which gives BA plus CA. Do remember, distributive property also, you see, if A is on left side, you have to maintain left side only. If A is on right side, you have to maintain right side only. Okay, clear everyone? Yeah, now very important point is, in matrices, if AB is equal to AC is given and it is also given that A not equal to 0, does it imply B is equal to C? A very important point. Now try to answer this question. Given AB is equal to AC, A not equal to 0, can I say that B is equal to C? Everybody please respond. Yes or no, please text. Yes or no, please text. Come on. Please text yes or no. Yes or no. Does it imply B is equal to C? Yes or no? Text, come on, text. I'd like to see your answers. Yes, no, yes, no. Please text everyone. No in Telugu. Ramesh? Okay. Okay. Fine. So equally I can find yes, no, yes, no, yes, no, equally almost. Fine. Now let me say whether it yes or no. Before that, you like the video, you subscribe. Okay, like the video, subscribe. Many are watching, but only 50% have liked it. So come on, like the video, we shall continue. Okay, fine. You see, dear students, this implies actually the answer is no. Answer is no. Answer is no. Answer is no because, you see, because AB is equal to AC in the sense you can write AB minus AC is equal to 0. So by distributive property you can write A minus B, A into B minus C equal to 0. It doesn't mean that. Now you see, in matrices, in numbers, suppose these are numbers, if same equation is given, A into B minus C is 0, so either this is 0 or this is 0. Suppose if this is not equal to 0, this must be 0 in numbers. But in matrices, the property is if product of two matrices is 0, it doesn't mean that either of them is 0. So there is a case, even though this is non-zero, this may also be non-zero, but the product may be 0. So from this property, what is that? Property number 4, AB is equal to 0 doesn't imply either A is 0 or B is 0. I can say from this, even though this is not equal to 0, this may also be not equal to 0. So you cannot say B is equal to C. So in matrix multiplication, a very important point is, so AB is equal to AC is there, and A not equal to 0, B not equal to 0, say A not equal to is there. It doesn't imply B is equal to C. It doesn't imply B is equal to C. Please note it. Okay, it doesn't imply B is equal to C. Okay, fine. Yeah. So what is property number 3? Property number 3 is if already equality is given, from this to this you can proceed. If you want to multiply with A, you can proceed either with pre-multiplication or post-multiplication. This is its converse. This is its converse. Got it? Both are not same. Both are not same. This is left to right. This to this. This is AB is equal to AC to this. Both are not same. Okay. Right? The next 7th property. 8th property. Yeah. You can say property number 8. And dear students, in matrices, do remember A into identity matrix of the relevant order or identity matrix into A is always A. So A commutes with I commutes with any matrix. Okay. Right. Now, next, dear students, A, B are two matrices. What do you mean by square of this? Multiplying the same matrix twice. A plus B whole square. Can I write like A square plus 2AB plus B square? Correct or wrong? Can I write it as A square plus B square plus 2AB? Can I write? Can I write? Can I write? Yes or no? Quick, quick, quick. Array, don't leave the class. Connect. Next 10 minutes are very important. So you are going to miss certain important points. Don't miss. Correct or wrong? In matrix multiplication, array, in numbers it is correct. So it is also like numbers, but there are certain peculiar, restrictions in matrices. The very peculiar property is AB not equal to BA. This is a special property of matrices. No zero divisors property. AB is equal to 0 doesn't imply A is equal to 0 or B is equal to 0. Because of these two properties, certain algebraic results of numbers we cannot take as it is. You see this, dear students, I mean to say here. So let us work on it. You see what happens. A plus B whole square means A plus B into A plus B actually. Correct? The meaning of this is A plus B into A plus B. Now you just apply distributive law. A into A plus B plus B into A plus B. Again you apply distributive law. This is A square plus AB plus BA plus B square. If these are numbers, I would have written BA as AB, it becomes 2AB. Correct. But here no guarantee that AB is equal to BA. So friends, A plus B whole square will be this itself. You have to stop here. Please don't write A plus B whole square in matrices as A square plus 2AB plus B square. Am I correct? Correct everyone? Am I correct everyone? So in the same way, you just try this. you see A plus B into A minus B. What happens in matrices? Come on, quick try. Come on, quick try. Many didn't like the video. Like it. Like the video. Subscribe. Like the video. Subscribe. And be active in the chat. Participate in the discussion. Yeah, you just simplify this. What is your answer? A plus B into A minus B. A plus B into A minus B. What is your answer? Come on, quick, quick, quick. A plus B into A minus B. What is your answer? This is, yes, apply this. You treat this as some single matrix. See, distributive law. A plus B into A minus A plus B into B. This is, okay. So now A plus B into A means A square plus BA, this is, minus AB plus B square. You see, if it is right side, you have to maintain right side only. In numbers, AB, BA are same, so we can cancel. It becomes A square minus B square. Okay. Whereas in matrices, these two need not be same. So that's it. A plus B into A minus B will become here A square plus BA minus AB minus B square. That's it. That's it. Got it? So be careful with matrix multiplication. Okay. So there are very, very important things. In matrix multiplication is not commutative. So zero divisors property is also not there. That is AB is equal to 0 doesn't imply A is 0 or B is 0. Okay. So friends, so we are left with 11 minutes. I am going to introduce determinant of a matrix, which is necessary for you. Yeah, you see, especially determinant is defined for a square matrix only. Determinant has meaning for a square matrix only. You see, suppose dear friends, A is a square matrix, say A, B, C, D. We define its determinant like det A, we write, or we can also write det A as the number AD minus BC. You know it well, AD minus BC. This number is called the determinant. Okay, this number is called the determinant, right? Right. This is we define. Why means Harsha? This is determinant. We define like this. Okay, right. Now, for example, A is a 2 by 2 matrix like 5, 6, 1, 4. So what is its determinant? Det A is nothing but 5 4s are 20 minus 6. 20 minus 6, 14 is its determinant. Okay, right everyone? So this is determinant of a 2 by 2 matrix. Now you must learn how to find determinant of a 3 by 3 matrix. Tomorrow physics sir is going to teach you vector addition, vector subtraction, and tomorrow means Monday. Tuesday sir will teach you how to do the dot product and cross product. Then you must recall me. This determinant is helpful to you, right? Yeah, you see, determinant of a 3 by 3 matrix. You see everyone, suppose a 3 by 3 determinant is given like, you see, A, B, C, D, E, F, G, H, I. So first learn it how to calculate. Y and all we'll see later. Arey yaar, today likes didn't hit the century. Come on, quick, quick. Like the video. Like the video. Arey Raghu. Laddu kavala naina. Like the video. Okay. Yeah, chalo. Chalo. Fine. This is a 3 by 3 determinant. Now, friends, the procedure is, thank you very much dear students who are listening to me. Really, I appreciate, I like you really. Yeah. Man of the match, 3 runs away. 3 runs away. Okay, right. So, how to find 3 by 3 determinant? Let me tell you, right. So, want to become man of the series. It's all in your hands. Okay, right. So this is first step is take the first number A, then remove this row and this column. You find this determinant EI minus HF. EI minus HF. Got it? First you take the first element, then first element, then remove that row and that column, this determinant, 2 by 2 determinant. Fine. Hey, century man. Chalo, got. Give a thumbs up. Century. Yeah. Come on. So this is first step. Then second step, after this, second step is, you can say, minus of this element you take, minus B, minus of this element, minus B. Now, you remove this row and this column, DI, you just imagine this row, this column are removed, DI minus GF, DI minus GF. This is step 2. This is step 2. Okay. Then third step, you can say, okay, this element plus C into, remove this row and this column, you got a sub matrix. Now this is DH minus GE, DH minus GE. This number is called determinant of the matrix. This number is called determinant of the matrix. Once again, step 1, step 1, DH, first take this element, remove this row and this column, EI minus HF. Then minus of this element you have to take, remove this DI minus GF, plus this element C into DH minus GE. That's all. Okay. Okay. Right. So, right. Now, let us take an example and try determinants of 3, 6, 5, 1, 2, 1, 4, 1, 5. You try to find determinant of this. Come on everyone, please practice this. First element you take 3, remove this row and this column, remove first row and first column, 10 minus 1, 9. Then minus of this element, remove this row and this column, this 5 minus 4, 1. The next, you can say this element plus 5 into 1 minus 8 minus 7. Simple friends, simple, very simple. So this is, we can say 3 into this determinant minus 6 into this determinant plus 5 into this determinant. Now this is going to be 27 minus 6 minus 35, which is going to be, this is minus 41. You can say this is 21 minus 35, you can say minus 14, correct? Yeah, right, this is 31, 41, perfect, minus 14 is the answer. So dear friends, everyone, minus 14, correct. So here you must know how to compute determinant, which is very, 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 very important. Eighth property with example, what is that bhaiya? AI into IA is equal to A. Arey yaar, you just take 1, 3, 5, 4, multiply with 1, 0, 0, 1, you just multiply, you will get 1, 3, 5, 4. Simple. Okay, right everyone, listen to me. So what are the important points we have discussed today? You see everyone, just in 1 minute I am going to close. If a matrix is given, how to write its transpose? Simply write rows as columns. A transpose whole transpose is equal to A. Then next, how to multiply a matrix with, how to multiply a matrix with a number. So just multiply each and every entry with a number. Then next, if you want to add two matrices of same order, you add the corresponding elements. Subtract, addition properties are very simple, you can simply add and nothing special here. And multiplication of two matrices is very, very important. You can multiply the matrices only when you see number of columns of the first matrix and number of rows of the second matrix are the same, then you can multiply, and multiplication will be in a different order. Please practice this. Take relevant sum matrices and multiply. Today you practice, and most importantly, in matrix multiplication, AB need not be equal to BA is a very, very, very dangerous property. You must remember, matrix multiplication is associative. If you want to multiply to a matrix equation with same matrix, then you just multiply either pre-multiplication or post-multiplication. No zero divisors property. AB is equal to 0 doesn't imply either A is 0 or B is 0. So distributive property, this is left distributive, right distributive, and most important, cancellation laws are not allowed. AB is equal to AC, A not equal to 0 doesn't imply B is equal to C, and A commutes with the I, then A plus B whole square. Such algebraic simplification, mind the two important points that AB not equal to BA. That's very, very important. You can't go directly. And determinant of a 2 by 2 matrix is very funny, 3 by 3 is very easy. Okay, that's all for the day. So why and how will depend on minor and cofactor. For that, this will be explained in the college. That's all in today's and yesterday's lecture. We discussed about matrix chapter related funda. Have liked the lectures yesterday's and today's? Everyone like it? I mean, do you like it? It's a question. Do you like it? Yeah. Fine. Haha, Baba. No problem. Fine. Thank you. See you, dear students. So, if you like it or don't like it, I will be continuing. Don't worry. So, yeah. But love you, boys and girls. Monday will come up with a new topic with fresh energy, right? Bye. Take care. See you.